Welcome back to ThinkCosmos. Today we're going to explore a radical idea. One that challenges one of the most fundamental laws of physics. What if the speed of light isn't constant? Since Einstein's theory of relativity, we've accepted that the speed of light in a vacuum, roughly 299,792 kilometers per second, is the ultimate speed limit of the universe. It's built into the equations that define time, space, and energy. But some physicists are asking a provocative question. What if that limit isn't as fixed as we thought? Let's rewind a bit. The speed of light plays a central role in how we understand the universe. It tells us how long it takes for light to travel from the sun to Earth, about 8 minutes. It helps us measure distances across galaxies. And it's why we can only see part of the universe. The part whose light had enough time to reach us. But some cosmologists have been puzzled by the early universe. According to the standard Big Bang model, the universe expanded incredibly fast in its earliest moments. But light shouldn't have had time to spread evenly across space in those first fractions of a second. Yet when we look at the cosmic microwave background, the afterglow of the Big Bang, it's remarkably uniform, like someone smoothed out the entire universe with a cosmic iron. To explain this, scientists proposed a theory called inflation, an ultra-fast expansion that happened almost instantly after the Big Bang. But there's another idea that challenges that theory. What if, in the early universe, the speed of light was much faster than it is today? This theory, known as variable speed of light or VSL, suggests that the speed of light may have changed over time. If light traveled faster in the early universe, it could explain how distant regions managed to synchronize their temperatures before expanding apart. And here's where things get weird. If the speed of light can change, then many of the physical constants we hold sacred might also be flexible. That means equations that govern gravity, time, and even the structure of atoms might be different in other parts of the universe, or in other eras. But this idea doesn't come without controversy. Einstein's theory of relativity is one of the most tested scientific theories of all time. GPS satellites, particle accelerators, and modern physics all rely on the constancy of light speed. Changing that would mean rethinking the very foundation of physics. Still, several scientists are working on VSL models, and they're not crackpots. They're respected physicists with peer-reviewed research. One of the leading voices, Joan McGeough from Imperial College London, has even published books and studies showing how a variable speed of light could offer solutions to cosmic puzzles that inflation theory can't. Critics argue that VSL breaks too many things, like the principle of relativity itself. But supporters say it's worth exploring because it could open the door to a new understanding of the universe. Let's imagine what it would mean if VSL were true. The constants of nature may not be constant. The laws of physics might evolve. Light might travel at different speeds under different cosmic conditions. Some even speculate that in distant regions of the universe, physics itself could operate under entirely different rules. And that brings up another mind-bending possibility. Could there be parts of the cosmos where time flows differently? Where causality isn't what we know it to be? Where faster-than-light travel, forbidden here, might actually be possible. It's speculation, but the kind that drives science forward. Science doesn't advance by holding on to dogma. It advances by challenging assumptions and testing the boundaries of what we think we know. And whether or not the speed of light is truly constant, the fact that we're questioning it shows that science is alive, curious, and fearless. Thanks for joining us on this speed-bending journey across the fabric of the cosmos. If you enjoyed this episode of ThinkCosmos, be sure to subscribe, share, and let us know your wildest theories. Until next time, stay curious and keep looking up.